Think we're live.
Okay, hello everybody. I'm glad to be here in one more episode of Deploy Friday because every day is a day to do deploy at platform stage. Today, we're gonna talk about Apache Kafka with several good friends of me. Let's start to Ricardo because he's a Brazilian like me. So Ricardo, hello.
Hey, Otavio. Hey, everybody. I'm so glad to be here and with this opportunity to talk about one of the subjects that I love the most, which is Kafka. Hey.
Yeah. And then we have an amazing guest, Anna McDonald. Welcome on board.
Thank you. Happy Friday, everyone.
Yeah. And here, a good friend and colleague at Platform Stage, Larry. Welcome aboard.
Hello, everybody.
Hello, everybody. So let's start the discussion about Kafka. One easy one question. What is Apache Kafka?
Right.
Don't
I'm
all answer
gonna
at once.
I'm gonna use the good manners here, so I will give the opportunity to the lady starts. So please, Anna, go forward.
Sure. Kafka, the easiest way to describe it is a durable log, which is money. And that makes it different from most all other messaging systems. So instead of something like, if you're used to, I don't know, Rabbit or any other messaging systems where a message goes in, you have to broadcast it out. As soon as it's consumed, it's gone. In Apache Kafka, it lives until your retention period, which is fantastic. I appreciate it very, very much. So if I had to sum it up, that is kind of how I would sum it up. It also is comprised of some delicious, wonderful APIs. My favorite of which is Kafka Streams. This is the best API, just saying. But then there's consumer, producer, admin, connect. So there's a whole ecosystem that's built around it as well.
Yeah, and on top of that, I would like to also share that it's kind of an opinion that I have about Kafka, which is I've been seeing a lot of developers talking about Kafka recently, and like 99% of them, without any blame, they think that Kafka is a messaging technology, right? And the reason why I say without any blame is because for a long time, Kafka was basically portrayed as a messaging technology, right? And but the reality is that it is considered a data streaming technology. So what that means is that along with messaging, we also provide, like Iana said, the log or the durable log subscription, which provides storage, right? So by nature, messages and or records, as we call it in Kafka, are not transient. They're durable. I mean, they're supposed to be durable, just like in a database. So that's one of the main characteristics of a streaming technology. And it also provides integration capabilities. So frameworks such as Kafka Connect allows you to bring data in, send data out with the concept of connectors. So it is a complete platform where you can also create end-to-end pipelines of data. So it's pretty cool.
Because I've read several articles about Apache Kafka, and as you said, a lot of people related with a message broker. And my second question is, what the difference between Apache Kafka and any kind of broker that I'm a Java developer, right? So that I usually use with GMS, something like ActiveMQ, RabbitMQ. What's the main difference between them?
I would say that the main difference, there's a lot of difference, but the main one is the how the messages are delivered to consumers. For example, so Kafka has this what we call pooling model, where it's the consumer's responsibility to go to Kafka and fetch the data, right? Whereas most of the messaging technology, some of them you've mentioned, such as JMS brokers, for example, it is the broker responsibility to push the message down to the consumers. So, all right, philosophically that's the difference. But what that really means in a real world is that standard messaging technology has a very serious problem of scalability,
Mm.
right? For example, it does make a difference for JMS brokers to have 10 consumers or having 10,000 consumers. In a certain point of time, the broker will become the bottleneck because all the heavy lifting belongs to the broker of pushing the message down. But in Kafka, it is the consumer that does the heavy lifting. So it is the consumer that goes to the broker and to pull the data. So for Kafka, yeah, you can have 10, 100, 10,000 consumers, and the broker will basically serve all of them with very little effort, right? So that's the key difference.
The same way you would have 10 or 1,000 or however many clients connecting to an SQL database, you're limited by the number of parallel clients you can run, but there's no automatic, I have to talk to all 10,000 the way
Exactly.
that
You're going to be limited about the bandwidth of your network card and the number of file handles that you can open in an operating system. So that's it. And I like your example, databases. Yeah.
Okay. So something Anna mentioned a moment ago, you said it's a durable log with a retention period. Define retention period. What is that?
So yeah, a retention period means, and it can be a period, can also be a size. It's a set of criteria that says, I want to keep my data until we hit one of these, right? And I think historically, I love Apache Kafka, but historically, when it came about, it was used for things like, clicks at LinkedIn, right? Very, very high volume. And as the use cases have grown, we've seen people have a need that, the idea that data is relevant for, let's say, 7 days, which is the default time, has kind of gone a little bit, it's opened up more. And so there's a focus now on kind of longer retention, right? So like, I've seen people keep stuff, say, well, look, I need to keep my stuff in Kafka for 3 years, 4 years, 7 years, however many years. So there really is a time. And then there's also a size limit. So some people will say, yeah, I want to keep, 4 gigs. Once it hits 4 gigs, start cleaning stuff up, the oldest first. So it's kind of up to you, and it's configurable how much data you keep inside of a topic / partition.
Okay, I didn't realize you could do that kind of sliding window. Can you also do just keep forever as well?
Well, yes, you can. There's Confluent has tiered storage, which we just released, and that basically allows you to shuffle to cheaper storage. And that for a while was kind of a bottleneck, especially in the cloud. Right, storage is expensive, and so that really helps drive down the cost of doing something, like in essence, keeping it forever.
Okay, so the technology can support it. You just have to think about disk size.
Yeah.
Okay. All right. Yeah, because I didn't even realize it could clear after a time. And so the main use case I would have thought, the main use case I've seen for Kafka or tools like that would be if I'm doing event sourcing, where I can just fire an event into Kafka as it happens, it stays there forever, and then I can have whatever other systems hanging off it that run through the stream history and denormalize to Elasticsearch or to MySQL or MariaDB or Mongo or whatever I feel like doing it. So that's a valid use case for Kafka then, where you would want probably the complete infinite history, correct?
You could, yeah. I mean, and I think it really depends. It depends, like, what your use case is for that infinite history, right? So how often are you rebuilding your event store, right? How often are you, using it? And there are ways to use Kafka as a cache, an example, right? Which is really what drives you when you do event sourcing, right? So I want to rebuild my cache from events. I can do it at any time. I can blow away my cache, right? It's optional when I do event sourcing. And so, there are things, like internal to, and like Ricardo talked about, we have APIs like Kafka Streams, has these internal state stores that can be built off a Kafka topic. So I think those go hand in hand, keeping that durable record, right, of actual state change, and then reading that in, compiling it, and making like a current state store out of it. So yeah, that's definitely a valid use case.
Okay. What are some other use cases where you'd say, oh, you're doing X, Kafka, go, yeah, that's what you want?
I can talk about that.
Some other sweet spots.
That's like why I took this job. I was a principal software developer for a very long time, and I wanted to see more how people use Kafka in the real world. So I took this job. So we see, I mean, there are some really cool Kafka use cases. My favorite are like stuff like ship to shore data, which is awesome. Transportation data, plow data, like how fun is it to know like how much snow people get? It's like fantastic, right? So I love like the, metric data. That's great. It's used in fintech all the time. There's just, like every single possible, use case that you can pretty much think of. We just recently, it's allowed to make it public that Kafka was instrumental in, collecting COVID-19 test results too. It's like backbone of it. So that's fantastic. There's actually a presentation at Kafka Summit being done by the team that we helped do that at the CDC. So I would recommend everybody check that out. So all the COVID-19 test results run through Kafka.
Nice. So those are all cases where you have a lot of different collection sources that can use their own Kafka database, and you then synchronize those together into a single stream that you can process when you do a data dump.
Exactly.
That's the generic description? Okay.
Well, exactly. And when you have disparate file formats, Kafka is a beautiful thing, right? Because we've got, there's so many connectors that out of the box work, file connectors, like every single thing you could, CDC, Debezium, shout out Gunnar, what up? There's just so many different ways to get data into Kafka. And then once it's in there, you can massage it, fix it, transform it, and then you can output it to where you need to be that like S3, Elastic, whatever you need. So that's a great use case, especially for volume. Nothing can handle volume like Kafka. That's my favorite thing. Like every time I meet a new customer, they're like, oh, well, we have so much data, just so much. And then they tell me how much. I'm like, no, you don't.
Oh, that's sweet.
Yeah.
They're like, we might have 1,000 records a minute. I'm like, and it opens you up to like all these amazing data collection that you could never do before because it just couldn't support the volume. So in case you can't tell, I'm like huge. I love Kafka, passion and fire.
Hadn't guessed at all.
So we mentioned a lot about data transformation, something like that, right? And usually when you read some articles about Kafka, is more about, okay, I'm using microservice, I'm using something like that, and let you, do some event source, something like that, event-driven design. My question is that the right way to use Kafka? Can I use to, event-driven design?
So by event-driven design, you're referring to the concept of the architectural components of separate producer and consumers, so they are non-blocking by nature, or more like using Kafka for implement the backbone communication backbone of your microservices, like
the backbone communication.
Got it. Yeah, I would say that's a typical use case, definitely, especially for the log nature of Kafka that primarily intends to ensure ordering. So that's what, if you implement event sourcing or CKRS, for example, keeping events in order, like the immutable ordering that when they happen, this is a key thing, right, for the architecture. So you can actually reprocess them from the beginning and reconstruct the state that you were trying to share with your microservices. So yeah, I would say that's a very common use case. Regarding transformation, that's the part I didn't get it when you were describing the problem. Kafka definitely has a different set of technologies to handle transformation. Namely, you can perform message-based transformation using Kafka Connect, for example. As well, you can perform more complex and stateful transformation using Kafka Streams or KSQLDB, right? Where usually developers would kind of change the domain module a little bit. You know the situations where one microservice generates an event that has, I don't know, 3 attributes, right? But the microservice B is interested on an information that has the same 3 attributes, but plus more 2, right? So there has to happen an enrichment on that event. So Kafka Streams and KSQLDB are proper technologies to handle that kind of situation, whereas Kafka Connect is more like okay, let me concatenate, let me replace strings, let me replace all the nulls with 0, things like that.
And is that a transformation you would make going into Kafka's log stream or coming out, or both?
That
like
is...
let's say I write a, like your example, I write a event to Kafka that has 3 data points in it, and I want the record to have those 3, but when it's read, I need to read it and then do some other lookups to attach other data to it? Or would I submit those 3 and then do an initial lookup to enhance it with those other 2 data points and then write that to the log? Or can I do both?
Yeah, I think the best way to describe is Kafka. I think the best practice is to store your events as is, as the inbound part of the architecture. So you have the immutable representation of what happened, right? And then each consumer will perform their, when I say consumers, I'm referring to Kafka Streams or KSQLDB, right? So each one of them will perform the needed transformation that they're going to mutate and create a new domain model that the downstream applications or microservices will be interested. But ultimately, all this data is still stored on Kafka, right? So in event streaming applications, as we call it, or streaming data applications, some other people call it, We have this notion of, we have an inbound topic where the raw data is stored, and we have stream processors, which can either be Kafka streams or KCQDB, which they're going to mutate those events, and then the result of that processing would be flushed out into a new topic, let's call output topic. And that output topic is going to be what your microservice is going to read. So ultimately, you still have the original version of your data and the transformed version of the data all stored on Kafka.
So I actually then have two different streams that get stored. One is the incoming data, one is incoming data after a transformation, and then potentially N of those that transformed streams.
Exactly. And what we are talking about here, if you think about it, is treating Kafka as your source of truth, of your system of record. I mean, all the data relies on Kafka, and you can mutate it whenever you want because ultimately it's all there.
And I think, you know, again, to like volume, CDC is a great example of this, right? For event sourcing, you know, just event notification, event carried state transfer, you know, any of the patterns and events that are popular, you know, can be derived from, you know, CDC data as well. So for a legacy use case, a lot of times what you see is people just, you know, throwing all of their CDC, you know, data from their old databases that can't take it, right? So, you know, they'll use something like Debezium, which mines like the bin log or, you know, your transaction log, whatever it is, throw all of that into Kafka and then use that to drive events downstream to new microservices. So that's like another pattern we see, and that makes it's possible because of the volume that Kafka can take, right? Because every single change in your database is flowing through Kafka.
So just as an example that's more, I think, familiar to web developers, if I wanted to really do analytics on my web server logs, then I could feed all of my, just every HTTP request is an event, throw that into Kafka, and then have a Kafka streams adapter that does DNS reverse lookup. So there's an IP address in the stream, and I want to know geolocation. So I have an Apache Streams process that's grabbing that and translating the IP address into, oh, this came from this continent or this country or this US state or whatever. And then another tool written in whatever that's accessing that data feed to say, oh, you're getting lots of traffic from India this week.
Yeah, and I think it's important to note that Kafka Streams is a Java library, just in case anyone isn't aware of that. So it's a microservice. Like that's the beautiful thing of it. You don't need any special infrastructure. It doesn't run where the brokers run. You know, you deploy it wherever you deploy your other microservices, right? And it connects to Kafka. So for anybody who is, you know, a developer who's used to Java, Kafka Streams is just going to be your home. It's just
how about those of us who don't do Java?
Well, you know, there's other libraries. We have consumer libraries for like every language, pretty much on the face of the planet. So however you're comfortable, you can get data out and into Kafka usually. I mean, I've been actually arguing for a native COBOL library for years, but like nobody wants to hear it. I just think it'd be neat, right?
Rock.
I know. But other than that, you're going to be set with a consumer application. Currently, I mean, Kafka Streams is only in Java. But, you know, for many people, it's just a much better, much more flexible alternative than some of the other stream processing platforms where you do need like an entire cluster to run it on, and you do need special knowledge. So that's just want to make sure that that's clear how that works, because that sometimes leads to confusion.
And
so if
just to add to that, if you're not a Java developer as well, you always can rely on KCQDB as well, right? Because KCQDB is kind of a DSL that has been built on top of Kafka Streams. So ultimately, it's Kafka Streams underneath, but you can express your event stream processing logic using a SQL-ish type of language. So it's pretty cool.
Okay. So I just want to make sure I'm wrapping my brain around this correctly, and that our viewers are as well.
Gotcha.
So like to use the example I just had of web server logs, because it's nice and basic. I have Kafka, which is where I'm just throwing all of my raw log files at whatever pace those are coming in. And that's written in Java. And then I would have a plugin to it that runs as part of the Kafka application that does that translation to geolocation, or I would have a separate Java application using the Streams API on another container that's reading it off and doing the geolocation lookup and storing it itself. Is that the second one there? You're nodding?
You could do either, to be honest, right?
Oh,
I mean, you could run a Kafka Streams application, which is just another container Java application that would read from that topic, do that do that enrichment, and then pump it back into Kafka, right? And then all of a sudden you have this enriched data that's in a topic where multiple people can get to it, whoever wants it, right? You could use a connector to put it in Elastic. You could use a connector to put it in Splunk, wherever you want it. Or you could do as like that whole lookup, the idea of like a geolocation lookup is a very common use case for ksqldb, as Ricardo said. Or it's also kind of common for people, that's could be a SMT and Connect, where every record you come, you write a special class and you can do a lookup as you're pumping it out, right, to another place. So you really have for something simple, like a simple enrichment, you really have like a ton of flexible options as to how you accomplish that.
Okay, and that means that I can also do them in whatever language I want, because it's just reading from one stream, doing some enhancement, and throwing it into another stream back in Kafka. Okay.
Yep.
But you can upgrade to Java as well. There's always that option.
You can always learn, right?
Yeah, you can always learn. But did you say something about QSQL? Is any kind of database, NoSQL database, SQL database?
No. I think we call ksqldb, right? Originally, it was named ksql, right? Called KSQL, as you call it. But currently, we call it ksqldb. But ksqldb is more like the purpose of is to address the problem that we're discussing here. Like, I'm not a Java developer, or I don't want to be a Java developer. I don't know why, by the way. But crazy. But I want to make sure that I could express my stream processing logic, but with a language that looks like a lot with SQL, right? So that's the main purpose of ksqldb. For the implementation standpoint, ksqldb is more than there's just a bunch of JVMs, right? That you're going to put them on a cluster, right? They're going to share the same name and they're going to form a cluster. And ultimately, they're going to act as producers and consumers to your Kafka topics, right? So architecturally, this is what ksqldb is. It does, because it relies on Kafka streams underneath, right? Like I said before, underneath is everything Kafka streams. It does have this its own state storage that is used to materialize all the results that are being computed, right? For example, imagine that you're performing an aggregation, right? I'm going to accumulate all the transactions that has been received for the last 10 hours, right? So somehow you have to accumulate this in memory, right? Or put more correctly, you would have to accumulate this in memory, but since you are the JVM, you should not do this, because otherwise you can incur in garbage collection problems, right? So what ksqldb and Kafka Stream does is to use something called RocksDB, which is a NoSQL database. So that's where we materialize all this data temporarily or transiently. And when we are done, we flush that back into Kafka, right? So that's what I said. ksqldb and Kafka Streams, ultimately, they act as producers and consumers to Kafka, right? So we call those stream processors. You want to build a stream processor, you can write your own Spring Boot for example, where Kafka Streams will be just a library in your class path, option A, or you can write your own Java application that is purely Java, Kafka Streams, option B, or I don't know Java, I want to write in SQL, ksqldb.
So in that case, you'd have, say, mainstream is your web server logs, and then you have another instance that's reading that, collecting up a day's worth of data into its local RocksDB instance, and I can read that over ksqldb, and then dumping a daily summary into another Kafka feed, for example.
Exactly. And just to make sure that this point, because it's a very recurrent point that we've discussed it with developers, I've used the term RocksDB here just to explain how the technology works, but ultimately, developers don't need to worry about if RocksDB is up or not, or how RocksDB works. It's an implementation detail.
Okay.
Right? You just have to worry about express your logic using SQL or Java. Go ahead, Anna.
I would also say too, the nice thing is there's been a couple of KIPs that have gone in to make what we call interactive queries much more stable. So let's say that you want to know, okay, well, I just want to know what the latest value is for this key, or this geolocation, right? Let's say you key by geolocation. You're like, hey, you know what? Let me see. I want to see how many people came over here from, Botswana, which is a beautiful country. And so I'm going to use it. Then you can do an interactive query over REST, and that comes right out of the box, and check that state store, right? in real time, anytime you want, which I think can be very powerful. There was a KIP that just went in to make sure that during, there's a process called a rebalance, right? Where if a new instance comes in, because again, right, we want to be fault tolerant and scalable. So, there are mechanisms to share the workload in Kafka for both Kafka streams, the consumer. It's just kind of an underlying principle. And there's a process that goes on. Used to be during that process, the state store would be unavailable, which made it, a little bit hard to use in real time because you don't want any downtime. And now you can still query state stores during, operations like that, which makes it really powerful if you want to use something like, hey, give me the latest state anytime I want it. So that's just something, if there's a lot of web, developers here, front-end developers, that I want to make sure to mention.
So that kind of becomes a kind of built-in event store or event stream during normalization, or there's your CQRS model right there, straight in Kafka.
Exactly. It's like that, and that's really, I think, underlying what the idea and intent behind KSQLDB is, right? It's supposed to, it's taking all of those principles and wrapping them up into one, right? So you have your stream processing, you have CQRS, you have all of these things in one in a language that many people are comfortable with, a SQL-like language.
Got it. Okay. Okay. Very cool. So then I have to ask the hard question, or Ottavio, did you want to ask us an easier question first?
Okay. We talk about a lot about microservice because microservice is amazing, is the newest silver bullets in the software architecture. But guess what? This year, a lot of people decided to hold back to just one single code, to monolith one. My question is, can I use Apache Kafka to integrate some asynchronous process, like given I have an e-commerce and I'd like to, on somebody buy something, I send an email. So I push this email event to somebody asynchronously process this email. Is that possible? Is not a good sample of Kafka?
It is possible, definitely. I mean, for the technology standpoint, is definitely possible because, like I said, like I mentioned before, Kafka has messaging capabilities, right? So yeah, it's possible.
And not only is it possible, we see people do it all the time, to be honest with you.
Yeah, yeah, exactly.
Like, I mean, it's a really common use case for using Kafka to handle asynchronous stuff like that, because it just waits. It's not going anywhere. That's the beautiful thing about it, right? It's durable lock.
Exactly. Yeah, yeah. And I think it is becoming, or it has been, a popular use case, especially because if you compare and contrast how other messaging technologies works, right? For any other messaging technology, such as GMS brokers or RabbitMQ or something like this, messages are meant to be transient, right? So what I mean by this is that when the very last consumer of a given application receives a copy of the message, it is the responsibility of the broker. I'm talking about other brokers, not Kafka, right? It is the responsibility of the brokers to dispose that message because it was not meant to durably store that message forever or for a given retention period, right? So this is how other brokers works. Kafka, on the other hand, everything is persistent. In a matter of fact, you cannot disable persistent in Kafka. There's no such thing. So it gives you, the consumers, to have not only the ability to receive asynchronously the messages, but if they want it, they can replay back that message as many times as they want it. So this is a powerful concept that Kafka unlocks that, I mean, it's pretty cool if you think about it.
And we see a lot of integrations too with third-party vendors, because sometimes, right, you don't get to pick. You're not designing your own front end, especially for something like e-commerce. So what I've seen a lot of is people going, okay, well, I'm kind of limited in what I can do because I bought this off the shelf, right? But over here, I need to do all this analytics, or for my email campaigns, or for my promotions, I got to do all this stuff in either another system. And so they'll use Kafka Connect or some other integration in Kafka to send all the stuff from the third-party vendor, like exactly what you said, right? So I want to do an email campaign, or I want to do, I need to somehow link up my ordering with my shipping. And they'll use Kafka as like the middle piece there to kind of ingest things from all their platforms. And it gives them more freedom, less lock-in, right? They don't have to worry about these things directly connecting anymore.
Okay. So we have some questions in the chat, which is great to see. Thank you to those who have sent in questions. Here's someone, YTA104, is asking about JSON schema support, which I think is part of a larger question. So what is the data format that Kafka uses? Is it JSON documents? Is it text blob? If I want to write something into Kafka, what options do I have to define that?
So Kafka is by nature schemaless, right? Everything in Kafka topics are just an array of bytes. So this is good because allow different programming language to serialize and deserialize data as they please, right? As long as they are conformed by the format of the bytes. But regarding schemas, right? This is the nice thing about Kafka. I mean, you can use whatever format you want. So JSON schema is one of them. If you want to use Avro or Protobuf or whatever, XML, for example, you name it, or you can use anyone. It's more about what is the convention that your producers and consumers are going to use to communicate, right? So there has to be a convention, right? When the producer writes the bytes into the Kafka topic, it has to write in a given way that the consumers will be able to read. So if it's using JSON schemas, a best practice is to, when you write your bytes into the topic, one of those bytes will represent the schema ID that will be hosted somewhere else. And let's not jump into the implementation details yet, but that somewhere else is going to be a schema registry, for example, right? And then when the consumer reads that data, it's going to read the bytes and it's going to know that one of those bytes represents the schema ID that he could use to fetch the schema and be able to read the data accordingly, right? So all of this, of course, is more like an implementation technique rather than, oh, Kafka only supports JSON schema or not. You know what I mean? Not sure if I was clear enough.
Yeah, so if I build my system on the assumption that I'm going to throw in JSON that it conforms to a certain schema on the source end, and I'm going to pull it out on the destination end, and some rogue producer decides to throw an XML string in there just to cause trouble, Kafka is not going to detect that or notice that. It's up to me to sort out at the other end, correct?
That's correct.
Shaking your head, yes, okay.
That's correct. Yeah.
All right.
We and the Confluent distribution of Kafka, we have a schema validation and a per topic basis, but that will be like a behavior that we include on Confluent's distribution. Pure Kafka is, there is no validation.
Okay. We have another question here. Which is this scenario the same as transaction log on a DBMS? If you're doing replication in a MySQL or MariaDB database, then it has a binary log that it reads out and feeds to other systems. It's
very similar.
And it sounds like you have an answer for this.
I do. I love this because it's the best way to explain it to people sometimes, right? So like your table in a database is just the manifestation of your transaction log or your redo log, whatever, bin log, whatever it is. Mm-hmm. So yes, I mean, it's the way that, and again, I mean, that's the way you love to explain event sourcing too, right? And so Kafka is a durable store of every message that's ever been produced, right? So there isn't really an aspect of change because every message by itself is individual, right? But yes, you can 100% think about it like that because do we ever delete things from a transaction log? No, right? We don't. It's just, it is what it is and we move forward. So yeah, I think that's a great way to think about it in terms of it being a durable log.
Okay, so it's like taking the bin log of MySQL and making that the primary thing you think about in a sense.
Yeah, exactly.
Okay.
Yep. And there's a pattern that we often use when we are discussing this type of architect with developers that we call, we stole it from Java actually. You know what we call Java write once, read everywhere. So basically, we like to use the same terminology with Kafka, which is write once and read several times. So it is all about treating Kafka as your single source of truth, so you can have multiple different consumers interested in the same data set, but each one of them are using the data set differently. So I can have Elasticsearch that is being used to provide the data for Grafana, for example, for monitoring purposes, or I can actually dump all the data using another consumers that is going to build up a data lake that I'm going to run a bunch of analytics on that. So when you start using Kafka this way, you start building architectures that are not only super resilient and scalable, but also it is a very good replacement for very expensive and databases, for example. If you think about what I'm describing here, people do this already, but instead of using Kafka, they use databases, right? Let's put all the data into a database, right? And then we're going to have a lot of different applications pulling data out for that database and then doing something useful with it. So you can do the same with Kafka, with the advantages of like having data in motion that's not necessarily going to slow down the broker. So that's how we like to address Kafka for as a system of record.
Okay. Now, if I'm writing a consumer, like we mentioned before, with a message broker, like RabbitMQ, ActiveMQ, whatever, it's doing a push. So anything that's registered, data goes in, it gets pushed out to those systems. With Kafka, it's a pull model. So Kafka just stores it, and then my client applications have to pull. Can you register to get triggered? Or do I just have to have, if I want my search index to be updated as quickly as possible, does it need to just sit there polling, or can I be notified, hey, there is a new event, you should grab it so you know to update your index?
I don't think you can I don't think you can do this in Kafka. I think the pull model is basically you're going to have your consumers in an infinite loop running on its own thread, right? And usually that's what the consumers does. I mean, they infinitely keep pulling the records, and they can optionally provide a timeout for that, where, okay, wait until that time and then you can do a pull again. But no, there's no automatic pushing.
Okay.
I don't know, correct me if I'm wrong, Anna, but I don't
No,
think
not at all. And actually, like that's an anti-pattern, right? That's batch thinking. We don't like that. Batch thinking is bad, right? What we want to talk about is getting as close to real time as possible, right? To the limit of real time, because that information, like nowadays, it's more valuable the quicker you can get it.
Yep.
So rather than say, oh, well, I want to be notified, then I maybe want to spin something up, you can continually pull, right, inside of the application. And let's say that you say, look, wait, I don't want to keep getting these small records. I have like bursty data or whatever. There are settings that you can have to say, only notify me when there's this much data, right? So there's efficiency kind of knobs that you can pull if you want to kind of tweak when you get to pull down a new batch, how much, right? Like Ricardo said, time, right? How long should I wait? So there's ways to be efficient, but really getting into the mindset of just continually running and continually processing this beautiful stream of events is where you want to be, right?
So if I'm writing a client that's doing some kind of denormalization off of the Kafka stream, then I would either just have it every 30 seconds ask for, hey, give me everything that happened in the last 30 seconds, or I just have a timeout on it, or
it's just a loop. You're just going to pull.
So I'm just going to have a burn loop that's asking for.
Yep. And then there's settings that you can say, look, maybe it's more efficient for me to process whenever, I'll wait till there's like this much data, right? Or I'll wait till there's this many, if you want to do it that way too. But that's definitely the way that you implement.
So there's going to be some kind of burn loop on the client side. Okay.
And for the sake of implementation, you've mentioned a term that's very interesting to comment out, which is, all right, instead of having the consumer worrying about, all right, let me grab what happened for the last 10 minutes. The best practices using stream processing is have a stream processor, whether it is implemented of KSQLDB or Kafka Streams, right? That is going to do that for you. We have the building blocks called windowing, right? Where you can create a processor that is going to bufferize all of this for you, right? It's going to dump into an output topic, and then your consumer, let's call it, it must be as dumb as possible, right? The consumer just needs to pull and fetch whatever has been put there for you by the stream processor, right? So you offload a lot of that logic. You should offload a lot of that logic in your consumer, right? To make it simple, reusable, and simple to maintain.
And then that stream processor, as we said before, could be a standalone microservice, or it could be a plugin running as part of Kafka.
Exactly. Or it could be, sorry, go ahead, Anna.
Well, not a plugin is running as part of Kafka. Like it's either going to be like a KSQL DB type operation, or it'll be a Kafka Streams service, which is a microservice.
Okay.
Yeah, it could be just as part of your microservices logic. So like Anna explained it in the beginning, Kafka Streams is just a library. Is a bunch of jars that you're going to put in your application class path in Java. So when you build up your JVM, you're going to have a bunch of dedicated threads we call tasks that is going to continuously keep running those processors, right? And the same JVM that you also have your logic to pull the data. So it doesn't have to be separated, right? You can optionally do this with KSQLDB, but it can do the same JVM, the same microservice as you call.
Okay.
And it's beautiful. It just really is.
Okay, okay. So go ahead, Larry.
The hard question I was going to ask before. So we've talked about what Kafka does, what it's great at, what it's real suited to. What would be a bad fit for Kafka? What's a problem space people can go, no, don't use Kafka, use this other thing?
If you need an SLA in nanoseconds, don't use Kafka. Kafka has an SLA of milliseconds. Don't use Kafka if you need nanoseconds. It's not a thing.
Okay.
Yep. And another use case that I kind of like a lot to explain of it, and we obviously, Anya and I, we obviously hear a lot about when and why I should use Kafka, right? I think it's kind of expected given the job that we do at Confluent. And most of the time, I hear, and I hear probably as well, some situations where developers are currently using some messaging technologies, let's call RabbitMQ, for example, right? And they come to us to asking, should I replace RabbitMQ for Kafka just for the sake of replacing and making it cool, right? And obviously, because we are all passionate about Kafka, going to say, yes, you should, because Kafka, it is indeed cool, right? But the reality is that, and this is kind of one of the things that we highlight for people to watch out, right? Kafka has a considerable operational burden when compared to other typical messaging technologies, right? So what I'm saying is that the same person that was used to maintain a RabbitMQ broker or cluster of brokers, right, is going to have a hard time kind of learning all the moving parts that from Kafka, because Kafka, I'm not sure if it's clear enough at this point, is not a messaging technology. It's more bound into being a database and a system of record than actually being a messaging technology. So therefore, you're going to have a more operational burden, right? So back to the example that I was giving before, should I replace Kafka RabbitMQ for Kafka just for the sake of replacement? No, probably you shouldn't, unless you were willing to observe the operational burden. So the reality is that we find a lot of developers that are not interested in observing the upside of Kafka, which is a lot, right? Kafka is not a very easy technology to maintain. That's one of the reasons why we at Confluent, we've been developing hardly the concept of fully managed services in the cloud, right? Because what we want is to provide developers with an endpoint behind the DNS where they can connect their applications to the cluster, and we maintain the cluster for you, because we've seen how complex Kafka is to be maintained, right? So I think it answered your question about what are the use cases I should not use Kafka. So the answer is when you don't have a very good or major upside in your team, or you simply don't want to spend time doing ops with Kafka.
Okay. So that problem is easily solved. You can run Kafka on Platform SH. Cool. So that one's done. What are some other application use cases where you'd say you're better off with a traditional relational database, for example, or you're better off with just build an Elasticsearch cluster or something?
I would say one of the things that I find is that cracks me up a little bit is when people say, and KSQLDB has come a long way, and it's getting to be where now I'm kind of going like this when people tell me, I'm going, maybe okay. But when you want to run a lot of like legitimate like statistical analysis, right? And they're like, can I use Kafka for that? Can I use KSQLDB? You can use KSQLDB as like an ETL system, provided that you kind of pipe everything to a different cluster. And the reason I say that is because would you let like marketing go nuts in your Oracle database and run whatever they wanted in production? No, you would not, because you just don't want people doing that. And so I've had people come to me and go, hey, I would like to do R type things, right? Or like, really mathy statistical things. Like, can I use KSQLDB for that? And the answer to that is not right now. No. What you need to do, but you can use Connect and easily pipe it to other systems that can do it, right? And I think it really is, as a developer, we all have to realize, like, there's a reason why there's not just one answer to everything. Applications do things and they do them well, right? The best ones I know of do a small subset of things really well, right? And so I think when you find yourself trying to push Kafka into one of those areas, like a specialized area, that's when you kind of know you need to back off, right?
Yep, I agree.
Okay, you mentioned something about database and message, and usually when you talk about that, you talk about size. There's one question from the audience, from Felipe Mapelli. Eu credo que lui é italiano, so I can move my hand this way. But anyway, what is the maximum size I can send by message?
So first of all, in Kafka, we don't call messages because that was commonly used in the messaging technology. We use the term records, right? So every record in Kafka is governed by a property from the broker that dictates the message size, right? So I don't remember on top of my head what is the number. I think it's 8 megabytes or.
So can I just answer this? Yeah.
Yeah,
So,
yeah. Go ahead.
You shouldn't be slinging around large messages, right, over the wire. Like that's a bad plan, my man. Whoever said that. So. Like some really neat things people have done. So like, again, like the Debezium crew, who is like my homies, I love them to death, is working on a couple of like, ways to think about doing this. Backdata, who again, like they put out some of the coolest stuff on GitHub. I love them. They have actually a serializer that creates like a pointer. So you can store like a large file somewhere else, and which is money. And that is my favorite pattern by far, right? Don't sling large messages around. I mean, the default in Kafka is 1 meg, right? And that's compressed, right? So, obviously use compression. Kafka supports a number of different compression types, but just don't sling large, like that's that's just a bad idea to sling that size of messages around. You're gonna hurt yourself.
So if I'm tracking large chunks of data, then you'd recommend push the large chunk of data off to file system, SQL database, the thing, and then make Kafka records that are references or pointers to that.
I would.
Yep.
Okay.
Like if I were designing an architecture where it would be running on AWS, for example, I would store all my data on S3, and my records would basically contain the ARN of the object store for all the objects. That will be a better
like if you're running
strategy.
A file upload service, let's say, if it was still the 1990s.
Yeah, yeah, exactly.
I still have to do it all the time on different websites. I'm like, man, come on now.
Okay, so that's another use case where Kafka is not ideal but can be used adjacent to, is when you have your records are large in size, you should be putting the data elsewhere and just passing pointers through Kafka.
Right.
Okay.
Okay, about Kafka product itself, we need to update sometime, right? Unfortunately, you need to update the database, Kafka itself. What is the life cycle? I mean, when it's returned a new version, the release cycle of the Kafka data as a broker. I mean, when it's happened, every 3 months, every year, something like that. And also, how hard is to upgrade Kafka?
Those are great questions.
Yeah.
So I recommend everybody follow the dev list in Apache. There'll be a call for a release, and then the release candidate will be out. People will vote on it. It's just like any other Apache project where it's like a community based, right? Upgrading Kafka, you got to read and then read it again, and then maybe have like a cup of tea or your favorite beverage. Come back, read it a third time. That's what I always recommend people do. Like everything that you need to know to upgrade is in there, but from different versions, right? There could be changes in the log format. There could be changes in the record format. There could be multiple steps. And this goes to Ricardo's point. You are not an organization that is comfortable with that investment and understanding of a distributed system. You should not be running it, because you're going to, or you should pay us or someone else to run it for you, right? Because it's a distributed system. It's complex, right? Kafka does support rolling upgrades, right? So it's not like you have downtime or anything like that, like a good distributed system, but it's complex and there's a lot of things that you need to be aware of. That being said, people do it all the time, right? Successfully. It's just, you have to be invested like anything else, right? And I would say one other point. Ricardo made a very good point about how people who are used to maintaining RabbitMQ kind of get really nervous about Kafka. That's why what I've seen is in some organizations, the DBAs will take it. So if you're looking to get Kafka into your organization, don't automatically go with your messaging team. Your DBAs may be better pulled for it. That's just a heads up from an organizational perspective, because they're used to upgrading databases. And let me tell you what, those are just as complex when you have to upgrade, and all the various things.
So if I'm running Kafka 2.4 and I want to upgrade to 2.5, it's more comparable to updating MariaDB or MySQL in terms of complexity and risk than it is to Elasticsearch or RabbitMQ or something like that. Or is it going to be more than upgrading a Maria database, for example?
I've never upgraded those in particular, so I'm not quite sure. I will say Kafka does a better job of having backwards compatibility than anything I've ever seen in my entire life. Like in terms of the clients and not breaking stuff, it's fantastic. So in that way, I think it is better. It's the brokers and the operational upgrades that I think are complex. It's not so much compatibility as it is making sure you do everything right in the right steps.
And I would like double what Anna said before about making sure you always read the discussions that are happening on the community before, because Kafka as an Apache project always discusses all the changes that are going to happen for the next release, right? And we've been talking right so far about, all right, what is the cost of upgrading this specific piece of the architecture, which looks like a database, right? Or looks like a messaging technology. But the reality is that Kafka is more about a central piece, right? When you upgrade Kafka, you also have to think about the consequences of your producers and consumers, right? Because there will be an impact there. So one good example is what happened on Apache Kafka 2.4, where, have you heard about this behavior of Kafka, right? Where we say, all right, if you don't provide a key, so what's going to happen is that Kafka is going to load balance across all the partition and distribute the data across all the partition evenly for you, right? And if you specify a key, is going to stick to a specific partition. That is still true, but what happened in 2.4 is that Kafka introduced the concept of sticky partitioner by default. So this is the default partitioner, for example, right? So what happens is that instead of evenly distributed across the partitions, the sticky partition is going to kind of use a better batching process to accumulate and make a better use of the network. But the consequences of this is that instead of evenly distributed the data across partitions, you are now going to use specific partitions instead of all of them, right? So for those of that were only concerned about the Kafka itself, they would, we upgraded, there was no mistake. And then the applications on the sides were start failing because they were relying on that logic, for example. So you can ask us, all right, so this is the problem about Kafka? No, it's not a problem about Kafka. This is a behavior that you should have read beforehand before upgrading your cluster, because that will create impacts on the downstream applications, right? So that's the type of thing that you have to worry about in Kafka Word.
So upgrading a single instance should be on par with upgrading a single instance of any other database. Once you're talking replication, you're talking a mess because replication, not because Kafka. Is that
right?
Well, yeah, and I do think, right, there are ways, and this is what I love about Kafka, right? There are ways to default to the old behavior to give everybody time. So you can upgrade your cluster and say, hey, I put out, I need to make sure I give my clients time to, either take advantage of this new behavior or do whatever's necessary to be safe. So I'm going to upgrade my cluster, but I'm going to set the level of whatever the behavior is that changed to be the one it is before the upgrade, to give everybody time. So there's like flexibility built in that allows you to, it really is very well thought out in terms of compatibility compared with other stuff that I've used again.
Yep.
Okay, you mentioned something about replica, so I can run several Kafka instances, right? And I believe that's why we have Zoomkeeper. This way I can have several Apache Kafka instances, My question is, I'd like to run locally. Is that possible to run Apache Kafka without the Zookeeper?
No, no, currently, regardless if you are in a multi-scale deployment or a local deployment for testing purposes, you still need Zookeeper because Zookeeper controls some aspects of the cluster that has to do with who is running the controller of the cluster. A controller is a building block of Kafka, right? I'm not going to put details on it, but the point is that there is definitely a need for you to have Zookeeper, and currently it's not something that you can get rid of, right? That's why we have this improvement on Kafka. We are removing Zookeeper from the architecture, right? And this is going to happen eventually. We're actually soon to make that happen. But no, you cannot right now, like July to 2020, you cannot get rid of Zookeeper, even in local deployments.
Yeah, but in local, I mean, it is in the tar. So it's not like, you know what I mean? If somebody's like wondering if they have to go out and get Zookeeper, you don't. Like if you just go to the quick Apache and download the tar, Zookeeper's in there. It's a little shell script. You go boop, and it runs. So it's not that bad.
And there's a lot of Docker containers as well. You can use it locally. Like there's some Docker compose files where they spin up Zookeeper, the brokers, all in the ones for you. So it's like if you're not even there. So developers are good at this.
Okay. You have 3 minutes left. So
I have to ask this question. I ask it to a lot of our guests when I can. Is the name, or the equivalent, is the name actually a joke on Franz Kafka? And if so, why? Or does it come from somewhere else? Where does the name come from?
Do you want me to tell you, Ricardo?
No, go ahead. Go ahead.
If there's a story behind it, that's even better.
Jay Krebs, who decided the name is, right, you know, was one of the 3 people who founded, you know, invented Kafka, was like reading Kafka and was like, hey, this is easy to say and kind of catchy. So that's why it's Kafka. There's no like, you know what I mean? There's not like a huge backstory there, but yeah, it's Kafka after Franz Kafka, but not for any reason particularly other than, and it is easy to spell. I appreciate that. I'm a horrible speller. I'm always like, yeah, I can spell Kafka. It's like a bug. Yeah.
So it's a lot like Python in that sense, or just named after Monty Python because Monty Python is cool. Why else?
Right. I would name something Lansbury after Angela Lansbury because I love her.
Good choice.
Yeah.
Good choice.
You know, the biggest issue to create a Apache product is basically the name, because you need to pick on one name that nobody has. And that's a hard one.
That's true.
And it needs to be catchy as well. So
Yes. Okay, let's use Artemis. Oh, yeah, already have one. So let's use some Greek mythology. Let's take Zeus. Let's take Cassandra. Done. So need to take somebody else's name.
And it's JavaScript.
Yeah. So that is, we are over the time right now. So thank you, Ricardo, for your time to explain me about what is Kafka. And that was amazing opportunity. Also, thank you, Anna. That was one amazing opportunity to learn a lot. Larry, do you have any final words?
Yes, thank you to both of our guests and to the viewers who are here with us live asking questions. That's always great to see. Join us again next week, same bat time, same bat channel. We're going to be talking about Open API and Postman with guests Lorna Jane Mitchell and Joyce Lin. So looking forward to that one. And with that, thank you. Thank you everyone for coming. And go out and deploy because it's Friday.
Bye.
All right. Thanks everybody.
Okay, first time.